This is Team Swizzle from Yaak Company reporting on our bike lift kit project for Dr. Elger's Mechanical Design Analysis class. Our group members are Michael Moreno, Chris Farnetti, Jason Hurst, and Wesley Donahoe. The purpose of this project was to create a bike lift kit that is a prototype of an actual bike lift that would go into your garage.
Our target customers for this project are professors and students. Professors need projects that students can do in the classroom to connect physics to hands-on real projects. Students are always looking for something cheap that they can build that's not going to cost a lot of money, that'll connect them to the projects and the equations they've been doing in class. Our product, when being designed, was designed to connect to the 5 human drives. The first of these drives is the drive to acquire, which is connected to by people wanting to acquire knowledge about physics. The second of these drives is the drive to bond, which is connected to by using this project in a group environment to help students bond into cohesive teams.
Our product connects to the next 3 and final 3 drives of learning, being safe, and experiencing by connecting the book equations we've been learning in class to an actual hands-on experiment while keeping on a safe and manageable scale. We are actually learning how basic pulley systems and moments work, and hands-on learning is always more attention than book learning. According to English version of Wikipedia, mechanical advantage is a measurement of the force amplification achieved by using a tool, mechanical device, or machine system. Ideally, the device preserves an input power. You know what? Layman's terms, mechanical advantage is taking the amount of force you put in, making it a lot bigger on an easier scale.
In this project, we used moment to increase the amount of force on the cable. Moment is equal to force times distance, where the distance from the center of the shaft to the cable touching the shaft is multiplied times the force in order to increase the force acting upon the system.
Basic toy motors, such as the motor used in this project, are based on the principle of 2 permanent magnets affixed around an axle with 2 temporary magnets affixed to the axle. There are brushes that alternate current to the temporary magnets, inverting their polarity. When the poles are the same, they repel, and when the poles are not, they attract.
For this project, we can calculate the total amount of power used by first calculating the amount of work. The amount of work is calculated as force times velocity. The force is calculated off of the weight of the object times gravity, with the mechanical advantage then taken into account. The velocity is then recorded and turned into angular velocity, which is multiplied times the force to come up with work. We then divide by time in order to get the total power. Pulse width modulation sends a voltage out for only a percentage of time based on the signal received from the microcontroller. Since it is only receiving this voltage for a percentage of the time, the motor will run at different speeds based on the amount of voltage it is receiving continuously.
Efficiency is usually thought of how well you do something or how much of your time or whatnot you're wasting. In the mechanical world, efficiency is described as the output divided by the input. It's a way of measuring your loss of heat, energy, or any other form of energy.
Our product uses a 2-to-1 mechanical advantage. It does this by doubling the force inputted when lifting the object. When we designed our product, we wanted it to stay relatively simple and easy to reproduce. We did this by using popsicle sticks, electrical tape, and key rings. This also gives students and teachers unlimited possibilities when redesigning our product. As you can see from the system diagram, the load has 2 separate tension cables coming off of it. This is so that the force coming off of the motor is doubled when lifting the load. The force coming off the motor can then be set by using the dial. In the electrical schematic, you can tell that the circuit is fairly simple and straightforward. As you can see from the flowchart, the idea behind our product is fairly simple. You turn on the product, the microcontroller reads the speed dial, and adjusts the motor speed to match the reading on the speed dial. As you can see from the Arduino code, the entire code for the project is fairly simple and only requires about 25 lines.
So your bike doesn't crash through the ceiling of your garage, we decided to add in a speed control. Having it go a little bit slower instead of at full speed sounded like a pretty good idea. This was adjusted by using the pulse width modulation as explained previously. We also decided that we could add a switch in to make it go reverse so we could actually get your bike back down from the ceiling. The resulting specifications of our specific design were 28 grams being lifted 7 inches over a course of about 2 seconds. These results compared to the actual full-scale model are going to be amplified exponentially because it's going to be going from 7 inches to 7 to 9 feet. And the 2 seconds, while being the same, we'll go back to our previous slide of crashing through the ceiling of your garage. Critical thinking is important in all aspects of life. Mechanical design is no different. We applied critical thinking to multiple facets of our design. For example, we had to figure out the best materials to use, the best structure for our design, and how to lift the heaviest load with the materials that we had handy.
In this project, we use knowledge construction to verify and complete our understanding of several key concepts, including mechanical advantage, moments, motors, pulse width modulation, power, and efficiency.
Communication is an integral part of success anytime you want to relay information, whether it be in group work or just presenting your own ideas. In our projects, we use communication through email, text messaging, notes, anything we could to let the others know what we were doing and what we needed from them. We work teamwork, the ability to see that someone else's ideas might and could be better than yours, shooting your own down if needed to, and promoting it elsewise.
Teamwork allowed us to collaboratively come up with better results in less time than we could have done individually.
Teamwork.
Looking back on the project, when using this in a real-life situation, the problem you are going to encounter is the amount of space it requires in the garage. To solve this problem, you could use a pulley system running sideways across the truss. The pulley system would slide into a track in order to allow it to move back and forth and up and down.